Hello and welcome to the basics of Lewis structures in chemistry. So, what a Lewis structure is the drawn out variant of a molecule. So let's say Cl2, chlorine gas, Cl2, and now this is just what the Lewis structure of Cl2 is. This is what it looks like. And in order to understand how you get to this point, how you draw out these molecules, you must understand the octet rule, which states that any given atom in a covalent molecule shares electrons in order to have 8 valence electrons. And this occurs in ionic compounds as well, but for the sake of simplicity, Lewis structures are only possible for covalent molecules, so we'll not go over ionic compounds. So what this is saying is that any given atom, which would be the Cl, will never have less than 8 electrons in the structure or more than 8 electrons in the structure. So now where this comes to play in Lewis structures is that each of these dots represents one valence electron respectively, and one pair of these, which is 2 of these valence electrons, is a lone pair. So that's that vocabulary term essentially. So this is one valence electron, this is another valence electron, and these are more valence electrons. Now this line is a covalent bond. So this bond represents 2 valence electrons being shared between this chlorine and this chlorine respectively. So this chlorine, if we count out its electrons, we have 1, 2, 3, 4, 5, 6, 7, 8. This chlorine has 8 valence electrons, so it meets octet. This chlorine, let's count it out, 1, 2, 3, 4, 5, 6, 7, 8. This chlorine will also have 8 valence electrons, and it also meets octet, meaning this is its structure. Alright, now, here's where things get tricky. To draw a Lewis structure, let's draw out the structure for NH3. This is just ammonia as it is like this. We would need to do 3 things. First, we need to add up the total valence electrons in this molecule. So nitrogen has 5 valence electrons. Hydrogen only has 1, but there's 3 hydrogens in this molecule. So we're going to do 1 times 3. So 5 plus 1 times 3 is 8. So this system, or this molecule, has 8 valence electrons in total. What this means is that when you draw it out, N, H, 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 this molecule can only have 8 valence electrons. So 2, 4, 6, draw out its lone pairs. 7, 8, nitrogen meets octet, and there's 8 valence electrons in this molecule in total as we count it out. But if you may notice that hydrogen, it only has 2. Each of these make 2, or each of these have 2 valence electrons, and they don't meet octet. So hydrogen is an exemption from the octet rule, in the sense that if you look at the periodic table, it only has 1 electron or 1 valence electron. And what this means is that hydrogen will only have this 1s2 orbital. So its electron configuration is 1s1, so that means that it can only have plus 1 more electron. Ignore that plus symbol. It's a minus symbol. But yeah, so hydrogen can only have 2 valence electrons because it only has 1 available electron to be shared. So this is the ionic, or this is the Lewis structure for NH3 ammonia. Now, let's move on to a chemical. Alright, now let's look at a molecule like COCl2. So this molecule looks scary to draw out because there are a ton of different atoms in here that you're gonna have to approach and solve them. So to figure out which one is in the middle, like which atom of in this molecule goes in the middle, is it carbon? Is it oxygen? Is it chlorine? Well, to figure that out, you pick the atom that is the least electronegative. This is an abbreviation for electronegative. So the least electronegative atom goes in the middle. You know which one is the least electronegative by looking at the periodic table and understanding that electronegativity increases as you go up into the right on the periodic table. So carbon is the least electronegative of this molecule. So carbon will be in the middle. And then oxygen, chlorine, and chlorine. So now let's figure out how many valence electrons are in this molecule. We will start with carbon. So 4 plus 6 valence electrons in oxygen plus 2 times 7, because there are 2 chlorines, 7 valence electrons in chlorine. So you get 10 plus 14 is 24. So you have 24 valence electrons. Now start drawing our dots. Dot, 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 dot. All of these valence electrons in this molecule. There are a bunch, clearly. Alright, let's count it out. Make sure we have 24 valence electrons, because as we know, you cannot go under or over 24 valence electrons in this total molecule. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay, so we have 26 valence electrons. That is too much. That is too much valence electrons. We can't have 26. So we're going to remove 2 valence electrons so that we actually have 24 instead. So let's remove the 2 valence electrons from this carbon. Now we have run into a dilemma. Carbon needs 8 valence electrons to meet octet, but there's not enough valence electrons to have 8 valence electrons on carbon. So in order to solve this issue, we must form a double bond. So as we know, this line represents a covalent bond, which represents 2 valence electrons, and molecules and atoms can form double bonds, which is just the same thing as one covalent bond, except it's another one. So in order to establish a double bond, we will remove 2 valence electrons from this oxygen, or it could be this chlorine, or it could be this chlorine, it doesn't matter. But for the sake of simplicity, we shall not go into resonance, and we will just say that oxygen forms a double bond with carbon in this structure. So we will remove those 2 valence electrons and replace it with another bond, which now gives carbon octet. It gives oxygen octet. Everything else already has octet, and there is 24 valence electrons in this molecule. So let's look at something with a triple bond, like nitrogenous gas, N2. So N2 is just 2 times 5 equals 10 valence electrons. So this molecule has 10 valence electrons in total. So let's draw it out. N2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So, I mean, already 6 times 2, that's 12, plus 2 is 14. So there's 4 more valence electrons than what we need. So let's get rid of 2, or let's get rid of 4, so that this molecule now has 10 valence electrons. So these two and these two. Now they both don't meet octet, so we are going to form, since we got rid of 2, we can now replace it with a double bond. We got rid of 2 here, and we can replace it with another bond. And look at that. That's a triple bond. And this meets octet. Now you can't go over triple bonds for reasons that is beyond the scope of this course. But you really all you have to know is that it goes up to triple bonds, and this is how you make double bonds and triple bonds. Alright, so now let's draw out a Lewis structure for a polyatomic ion. Something like hydroxide, OH, with a -1 charge. Now this -1 charge makes everything different in this Lewis structure, because this -1 charge means that this molecule gained a valence electron. Here, let me switch around that plus sign, because that means that it lost one. So this means that it gained a valence electron. So let's draw this out. Per usual, here's our skeleton. Now it would be 6 plus 1. 6 valence electron oxygen, 1 in hydrogen, and this is 7. So as you know, this does not meet octet for anything, because if there's 7 valence electrons in the molecule, that means that nothing can have 8, because there's not 8 valence electrons in total. But that's where this plus 1 electron comes in, where you do 7 plus 1 equals 8 valence electrons. So this is how much electrons are in this molecule. So let's try it out. Let's try out the lone pairs here. And wow, look at that. It already meets octet, and it meets 8 valence electrons. But to specify that it is an ion, we draw out these little brackets, and we put the charge. So here it is. This is the Lewis structure for the polyatomic hydroxide. Now let's do something else. You can solve this one out on your own paper. If you would like to pause, I'm going to choose ammonium, NH4. So ammonium has a 1 plus charge. So if you would like to pause the video, you can solve this out, but I'm going to solve it on my own. So ammonia is 5 plus 1 times 4 equals 9 minus 1, because there's this plus charge. Plus 1 means it lost an electron. So minus 1 equals 8. Now let's draw out this structure. And this all meets octet, except for the hydrogens, which are exceptions. Now the brackets. And here you go. There it is, the Lewis structure for ammonium NH4 1 plus. Alright, and that is the conclusion for the basics to Lewis structures. I mean, as you progress on courses over chemistry, you see things like expanded octets, you see free radicals, and many, many more. But this is it for now, and hope you guys have a good time with whatever you're watching this video for. You know, whether it's a quiz or a test, I wish the best of luck to you all.